Hello, I am Amar Huzaifa as one of a member in Group A. Today, I would like to introduce to you about our group assignment. Our presentation divided into 4 parts. The first part is to explain the statistic concept that we use in our assignment. The second and third part is descriptive statistics. Last but not least, the last part is analyze the data. We have done confidence interval, hypothesis test, and linear regression.
We classify the countries into a few categories based on type of incomes and development of the countries. We divide the countries to low income, middle income, and high income countries. Low income countries have GNI per capita that is less than $1,026, whereas for middle income countries it ranges from $1,026 to $12,535, and it is more than $12,535 for high income countries. Countries are also subdivided into developing countries and developed countries. The criteria of being classified as a developed countries are economically successful and measured by gross domestic product (GDP), which shows a country's economic status. Developing countries are countries where living standards, GDP, and economic strength are weaker than developed countries in comparison. A few examples of developing countries are Brazil, Egypt, India, Malaysia, and Mongolia. Canada, France, Turkey, Australia, and South Korea exemplify some of the developed countries. One of the topics that we focus on is the literacy rate of youth. Youth literacy rate is the percentage of youth ages from age 15 to 24 who can both read and write with understanding a short, simple statement about their everyday life. However, not all countries have their respective data entries. Therefore, the data set of all countries is incomplete. After screening, our sample size for developing countries and developed countries is 64 and 8 respectively. We have computed the summary statistics based on our sample, and we have obtained the following summary statistics.
Now we'll look at the graphical representation for the literacy rate of youth. So first is histogram. A histogram is a graph with vertical column which represent the frequency of a data point or range of data points occurring in a set of data. The histogram on literacy rate of youth for both developing countries and developed countries showed a left-skewed histogram. This shape indicates that there are a number of data points for the literacy rate of youth, perhaps outliers, that are greater than the mode.
Now I'll discuss about graphical representation. We use bar chart to show our calculation. For mean of literacy rate of youth total, we divide into 3 groups by income class, which are low income, middle income, and high income countries to make it more precise. As you can see here, this is bar chart for mean of literacy rate of youth total in 2018. Next slide is the bar chart of mean of literacy rate of youth total in 2010. To sum up, bar charts are usually used to make comparison of data. The mean of literacy rate of youth in high-income countries is the highest in both 2010 and 2018, whereas it's the lowest in low-income countries. This clearly describes the development of the country plays an important role in the literacy rate of youth.
Slide is about the block spot of literacy youth in 2010 based on the incomes of the country. For the low-income country, the minimum is 44.30171, the quadrant 1 is 60.82317, the medium is 77.34463, and the quadrant 2 is 82.37673. The maximum is 87.40883. For the middle income country, the minimum is 79.52862. The quadrant 1 is 87.215355. The medium is 95.15069, and the quadrant 2 is 98.3090909. The maximum is 98.76235. For the high income country, the minimum is 95.45447, quadrant 1 is 97.7174, the medium is 98.6426615, the quadrant 2 is 99.0131075, and the maximum is 99.75182. The following slide is about the block spot of the literacy youth in 2019, and this is the graphical representations.
So for this slide, this is actually a slide about box plot. So box plot is actually a standardized way of displaying the distribution of data based on a 5-number summary, which is the highest sample, which means maximum value, and then upper quartile, median, lower quartile, and also lowest sample, which is also the minimum value. So a box plot can give us information regarding the shape, variability, and median of a statistical data set. So it's particularly useful for displaying skewed data, and it can sometimes provide us with the information of the outliers too. So in this case, the box plot for the literacy rates of youth in low-income countries in 2010 and 2018 is much longer than in high-income countries, which indicates the literacy rates of youth is much more spread out in low-income countries.
For the part 3, we will know more about primary completion rate. So what is primary completion rate? primary completion rate is the number of new entrants in the last grade of primary education divided by the population at the entrant age for the last grade of primary education. Next, dataset given on all countries is incomplete. Only some countries have complete information on the primary completion rate. After screening, we obtain the following samples. Here is some summary statistic we can obtain from this sample.
Moving on with graphical representations for primary completion rate. So first of all is the box plot. So by looking at the above box plot, the developing countries showed longer whisker length and bigger box size compared to developed country. This indicates big range and showed more variable data in developing countries. Next will be histogram for developed and developing countries. So the above histogram for primary completion rate for both developing and developed countries showed a skew to left histogram. So next will be bar chart for mean of primary completion rate. So from the above bar chart, we can compare and tell that the mean primary completion rate in developing country is lower than in developed country.
The following part would be data analysis, in which hypothesis tests and also linear regression will be carried out. In the data analysis part 1 and part 2 would be the hypothesis test, and part 3 would be the linear regression, and for part 4 would be the credit to the contributions of our group members.
Is the mean literacy rate of youth for developed countries equal to that of developing countries? Okay, so how can we calculate the confidence interval for literacy rate of youth? From the data that we have from the question itself, we can get the value for degree of freedom, estimate of standard deviation, the margin of error, and that from that information we can get the confidence interval for this literacy rate of youth. Then the value for 99.5% confidence interval is as in the slide.
Here comes the hypothesis test part. Firstly, the left blank is all the definitions we used in this test, for which I will not introduce them one by one, and we have two hypotheses in the right. The null hypothesis is the mean literacy rate among youths from developing countries and developed countries are not different, and the alternative one is the mean literacy rate among youths from developing countries and developed countries are different. This means literacy rate among youths from developing countries is less. Since we have already computed two sample sizes, two means and two variances, it is not that difficult to calculate the degrees of freedom. We should notice that we suppose the standard deviations of the two populations are unknown and unequal. In order to use proper formula, also, we can compute estimate of the standard deviation of x bar 1 minus x bar 2. Finally, as we know it is a one-tailed test, we compare test statistics value of t with the critical value of t by setting alpha as 0.5%. We can easily draw a conclusion that mu1 is less than mu2.
Is the mean primary completion rate for developed countries equal to that of developing countries? Okay, for confidence interval for primary completion rate, it is the same as how we calculate for the confidence interval for the literacy rate of youth. So, the value for 99.5% confidence interval is also as stated as in the slide.
Likewise, we can also make such two hypotheses in this part like what we have done above, and the null hypothesis is that the mean primary completion rate from developing countries and developed countries are not different, whose alternative is that mean from developing countries is less. As we don't think we know parameters from the populations, we still suppose the standard deviations sigma 1 and sigma 2 of the two populations are unknown and unequal. So, with the same way, we can compute and compare the test statistics and the critical value, from which we can, similarly, know the primary completion rate from developing countries is less than from developed countries.
Last but not least, we have also carried out a simple linear regression analysis with primary completion rate as x, our independent variable, and literacy rate of youth as y, our dependent variable. We used the dataset from stage 1 to carry out the analysis. However, our dataset is incomplete as not all countries have data for both variables. Thus, after screening, we obtain a sample size of 51 countries. Using the raw data from that sample, we obtain this regression line with a relatively small coefficient of determination of 0.3734. Some x values are more than 100, which is unreasonable, so we have cleaned the data by replacing those values with a value of 100 and obtain this regression line. We then decided to focus on the upper right region of the graph, where most of the data points lie. Taking only data points for x greater than 85, we obtain this regression line. Lastly, after further analysis, we found that the best way to analyze our two variables is by removing some outlier points, giving this graph with a relatively larger r-square value. These are the calculations to obtain the regression line equation. We have a value of a as negative 35.4213 and a slope coefficient b of 1.3627. The linear correlation coefficient r is 0.9594, which is close to 1 and indicates a strong linear relationship between the two variables. The coefficient of determination is 0.9206, which indicates 92.06% of the total sum of square fit this regression model. The following table shows the contribution of each 9 members in our team. And here are the references used for country classification. That is all from us, Group A. Thank you.